Hello, everybody. My name's Dermot O'Shea. I'm the host of the Antenna podcast. And today I'm delighted to introduce Baha Badran. Baha, do you want to give us an introduction to yourself and maybe tell us all about your career to date?
Sure. Thank you, Dermot. My name is Baha Badran. I'm the Global Head of Engineering at Taoglas. I've been with Taoglas around 9 years. Started my career with Taoglas as a senior antenna engineer and made my way through a couple of positions, and now I head the team of engineering globally at Taoglas. Myself, I have a bachelor degree in electrical engineering from Palestine, where I was born and raised, and from An-Najah National University. After that, I went to the UK and I had my master degree in personal mobile and satellite communication, and that what got me actually into RF and
And what,
antennas.
what piqued your interest in, like, what was the first kind of moment when you thought, hey, RF and antennas is interesting? I like the look of that.
Yeah, no, it's quite interesting question. Yeah, so really, I always like to be focused on the wireless communication side in the electrical engineering, and rather than the looking at the power uh, design or power electronics. That's what I wanted to always think about, and then when I did my master, kind of I was slightly focused on antenna engineering. I found the topic is quite interesting, quite challenging, and requires a lot of problem solving skills as well. You know, it's
Yeah. And
you're
what
dealing with, yeah.
a lot of people call it black magic. Like what's your opinion on that? I presume you've heard that a lot.
I did, and I use it a lot. It's yeah, exactly. It's black magic. It's part of why I like it and why sometimes it's very challenging. It's because you're dealing with electromagnetic waves, something you cannot see. It's like, okay, we have Maxwell equations. We have a lot of science behind RF, but when it comes to designing an antenna, how how you're gonna see or know exactly how it's gonna work. So with time and experience, you kind of start seeing where you are on your design, how good or bad it's gonna be, and that's why we use chambers, and or you need to use not any equipment, simple equipment. You really need to use sophisticated equipment. So yeah, it's black magic definitely, because it needs a lot of knowledge, not only in RF but also in everything in electrical and mechanical engineering. It's anything could affect the signal strength, and if, as we know, everything these days is mostly wireless, and if you don't get good reception, it means your device at home, whether it's a doorbell or a camera or a TV, you're going to be suffering with these kind of things.
And so go back to so you did your masters in the UK. Where did you go? Where did it take you from there?
Yeah, after that, actually, I thought, okay, my goal in life at the time when I was student was to do electrical engineering degree and do a master degree in the communications field, and then work with a company to learn more and practice my degree. And actually, I my plan was to join a company like Nokia at the time, and that's what exactly happened. So in 2007, I joined a company founded by and part of Nokia at the time called Vertu, where we were focused on luxury mobile phones, and we're pretty much metal and luxury material used. So it's the challenge was quite high. So I had access to design tools, to equipment, to production environment, everything, and this is where kind of enjoyed actually learning and practicing uh, the antenna art, I say it, okay, and an RF design. So that's really what. pushed me the extra mile in my career, to develop that career. Then after that, of course, I worked in another company where the focus was on a different field in smart metering, and it was a big project here in the UK, smart meters and communications hub. And after that, I joined Taoglas, where it's also, again, it's different, but we are not only focused on one area, but we are focused on pretty much multiple use cases and verticals in the market, which is actually more fun as well.
Yeah, and the mobile phone you mentioned, I think I saw one of those they had a store in Shanghai. They were like the diamond crusted and gold plated cell phones, right? It was like a high end cell phone type
It's
product.
actually not gold plated, it's solid gold.
Solid gold.
Yeah.
Wow. Okay. Yeah. At the time, I was like, yeah. I'm not sure. Even if I had the money at the time, I'm not sure I would have been comfortable walking around with one of those on my head. It's a bit, but I suppose that's the appeal of it, right? It's like, look at
It
me. I've
is.
got I don't know how many thousands of dollars the phone cost, but
It could be as high as 1 million, to be honest with you.
wow.
But
Yeah.
yeah, but the nicety about it, it's not only like a normal phone, but it uses good technology. It also uses like luxury materials, and
Mm,
this is for engineers. Like it's how can you design a product that on the mechanical side everything has to be spot on and precise, because you are developing all these metal components that they need to be precisely, designed and machined and polished. They have to look prestige, and then that makes things for RF extremely challenging. So
mm,
definitely, we at the time we pushed boundaries with metal phones. Before all the, many manufacturers now are using metal. This is where we used to use that material, and it was fun to see it done. But the challenge again, it's how you design an antenna that works in such an environment, and then you go and manufacture thousands of these products. So that's the fun part of it. Yeah.
And would you say that sounds like, is that the most challenging device you've ever worked on? Because a cell phone today, I look at it, it's got like multiple cellular, you've got multi-band GNSS, NFC, ultra wideband, Bluetooth, multi-band Wi-Fi, um, NFC, right? And then you're putting in all those, gold and diamonds, and like that has to be the most challenge. Is that the most challenging project you've ever worked on from an antenna design perspective?
It is considered one of the most challenging, to be honest with you, in different aspects. Okay, but now at Taoglas we are also dealing with, equally challenging designs. But when you are working on the design from A to Z, for let's say 2 years on one project, and sometimes we used to have 2 or 3 antenna engineers on one project, working with the industrial designers from the very early stage all the way until they build the phone in the production line. So it is, you are monitoring the design from very, when the phone is on a sketch on a piece of paper, to give direction to the industrial designer, all the way to where you are starting the design and prototyping, doing passive active testing, and then monitoring, let's say 20, 30 phones in terms of like performance and repeatability, and then developing test jigs for the production line. And then you don't stop there. You travel to the production and component product manufacturers, and you see all that happening. And then at the time we used to wrap antennas with leather. So I know, at Taoglas we say, okay, you have plastic or a cover on top of the antenna, how it detunes the antenna. But when you use leather, for example, or fabric, or that's another layer of complexity you are adding to the design. So it's quite challenging. But I think at Taoglas the challenge is a little bit different, because you kind of have to know, as a designer, you need to have that level of experience and background. So when you are talking to, let's say, a customer who's developing a device, you need to be in their shoes. So you need to have that level of mechanical engineering, hardware engineering, RF engineering knowledge to try and understand how you come up with a solution for the problem.
Yeah, so it sounds like a very much a partnership approach with your customers. Like I know in the past, I've seen antennas be an afterthought and definitely not have the kind of involvement that you just described from the team, the amount of people involved. It sounds like you're saying antennas is really an advanced part of an engineering project.
It is definitely advanced part, and it's because antenna, anything in the product could affect and interact with the antenna itself. So you cannot just isolate it from everything else. It's not like a little module or a component on the board you can add at any time or swap at any time. So it's anything we've seen in my career. I've seen something simple things like you're designing a product, you're almost done, and in the production line, for example, you receive a sample, a product sample, and they put a metallic sticker or label right next to the antenna. You look at it, you think it's a piece of paper, okay?
Mm.
But then you spend a week to find out it was actually metal. So yeah, you deal with all sorts of things that you need to be aware of to try and optimize and fine tune. And as you know, Dermot, time is money. So all this knowledge help the customer to get their product to market, and also accelerate the learning curve for the engineer and for myself as well. The more we see, the more problems we can solve quicker, and that's the, I would say that's the fun of RF and antenna engineering.
Awesome. But, I think anybody listening to this podcast probably fancies themselves as having a go at it themselves, maybe, or doing more of the work themselves. Like you've highlighted like one that I didn't even think of, which is the metal label. But like, what are the main issues that you see, you know, when it comes to people getting their device ready for antennas even? Like, what are the main pieces of advice you'd give anybody as they approach, hey, I'm going to do this antenna, or I'm going to integrate this antenna in my project? Like, what are the main kind of, please do these things as a bit of advice to them?
Yeah, definitely. First of all, think that your device, if it's a wireless device or you need to use wireless communication, you need an antenna inside the product. Okay. Now that antenna is going to be responsible to send and receive the signal. So if you improve the performance of that antenna, it means you're going to get better coverage, you're going to get better battery life if it's a battery powered device, and you're eventually going to get happier customers. So think about antennas as early as you can in your development. Define what radio technologies you need to use. For example, if you want to use cellular radio technology, it means maybe, and you want to cover, for example, lower bands like band 12 for AT&T in the US. It means you need to operate at 700 megahertz. Your PCB size need to be, for example, 100 millimeter or 110 millimeters long. Where if you want to use Wi-Fi, for example, you can live with a smaller device because it operates at 2.4 gigahertz. So pay attention to the radio technologies you're using. Think about antennas as early as possible, and also pick the right solution that works for your manufacturing and assembly as well, because that is crucial. You need to think about consistency and repeatability in performance. If it's not easy to assemble the antenna, it means that you're going to get a lot of variation. Okay, so do things right as early as possible. That's going to save you time, and if that will help you also to pass certification from the first time. So, and it's best always to consult with the expert about this.
And okay, so fair enough, but how do I start? Like, what kind of equipment do I need to test? And what should I be testing in the early stages, or what type of equipment, say, can most people kind of afford to buy? Because we can't all get anechoic chambers, right, with call boxes like you have in Taoglas. But like, what's a good place to start? What kind of tools are available to engineers to use
Yeah,
for design and test?
there are multiple tools. There are simulation tools, and there are the expensive ones. There are the cheaper ones. Okay. Again, it requires some RF knowledge to do that, but it's always good to rely on existing knowledge. For example, if you go to Taoglas website, okay, there are lots of course, we have all our data sheets with a lot of details, application notes, but also if you go to the antenna integrator at Taoglas, for example, and you want to add embedded antennas in your device. So you can go there, create your board, add whatever antennas you want, submit your design, and you get a report within 24 hours. Now, this is really great tool to use before we start testing and all that stuff. You need to get a feel of what performance level you're gonna get on a PCB of a certain size. Okay, that's gonna help you on the doing a placement exercise on your PCB for antennas, for other components. It's going to get you an estimate on performance as well, which means you can at least sign off your concept and move to the next step and go and build, for example, PCBs. Once you build PCBs and you are looking to test something, then you can look at having, for example, simple VNAs, vector network analyzers, where you can look at S11 and return loss measurements and make sure the antenna is tuned in band, etc. It's yeah.
Just before you move on, Baha, sorry, maybe explain to people S11 and return loss, what it is, why it's
Yeah,
important.
it is very important. Why? What is that? It's really a measure of showing how much signal goes from, let's say, your radio module to the antenna and back from the antenna to the radio module. So you want to make sure that all the signal, or the majority of the signal that comes from the radio module, gets transmitted, and also you receive the same thing. So it's to ensure also your system is matched to a 50 ohm. So in simple words, if you are able to see that you are getting a good return loss, a reflection coefficient, it means you are minimizing the unwanted reflections. And those reflections, if they are high, they will be actually dissipated as heat. And that's going to reduce your system antenna efficiency and system performance, and also eventually reduce your battery life as well.
Okay, so not just affecting your ability to transmit and receive, but also to the detriment of your power
Of course.
and battery
Yeah.
life. Okay.
Yeah.
Very good. So, okay. And then I hear a lot, though, in that process, people talk a lot about custom antenna design, and I know at Taoglas you have a lot of standard off the shelf products, but you're also offering custom design services. Like, when, as say somebody developing a product, what should I think about there? Should I go, I need a custom design, or like, how should people think about that?
Yeah. Again, as a free documentations and tools, if you go to Taoglas website, if you look at our services workflows, we show actually a product development workflow from start to finish. Okay, so you can see the first thing to do is what we call system review and analysis. Okay, initial system review and analysis. So that will allow you to understand or share and understand what needs to be done to your device. So define the problem and then start seeing, or for example, which direction to take. For example, okay, we spoke about customization, but Taoglas, for example, offer many antennas in different form factors, in using different mounting solutions as well. So if you start thinking about this antenna as early as possible, that it's highly likely they're going to use a standard antenna, which then you don't need to invest money to develop a custom solution, and you will also, more importantly, finish your product quicker and get to market quicker as well. But on that workflow as well, we show if you cannot use a standard antenna, there are options for a custom solution. And of course, customization is a big field, and it can be anything in any shape. There are multiple antenna manufacturing technologies that we use, and the goal is to find the right solution for performance, for mechanical integration, and for assembly.
Very good. Yeah, so plan early on, prepare early on, consult earlier,
Yeah,
and then your chances of using standard products are higher.
correct.
Okay, very good. So last question, Baha. I think we all see, AI becoming a massive part of our lives, and especially driving a lot of innovation and potential for businesses. Like, I've heard physical AI being the importance of that being mentioned in the industry, and antenna engineers are going to be a really important part of that, right? So how I've seen your career trajectory. It's awesome to watch it, as a young engineer in Palestine, and now you're head of global engineering in a multinational company dealing with thousands of projects a year across the world. Any advice for young people looking, how can they get into antennas? What should they do? Any advice for people on the outside looking in?
Yeah, it's the RF and antenna field is quite interesting. It's probably one of the most advanced areas in for studies and universities. You see people doing high degrees and PhDs in antenna design. So if definitely it's an interesting area for anyone to get in, where you get you have the ability to learn, you have the ability to build something, and you have the ability to test and see what's going on. So it's, to me, it's for me at least, and probably for many engineers, it's like a really nice thing to do and have that thing, having the ability to exercise a lot of engineering in a lot of engineering areas. Okay, it's you make use of what you learn first, and then you develop new skills, and you continue to learn more and more and more. So, and that's what's fun about antenna engineering, and especially what we do at Taoglas. And I worked, and we did raise and developed many interns into this field, and it's quite interesting, and we feel proud to see these guys. So I really encourage people, because it's a big topic. And in one last thing also, I don't think we're going to go back to the wired communication anymore soon. So everything is becoming wireless, right? So I don't think anybody's going to invent something that's going to replace an antenna. So it's
Yeah.
definitely something we all need. And how AI improved that. So it's again, it's with all these challenging we discussed, or challenges we discussed on the call, Dermot. This is where intelligence, let's put it this way, and then AI is going to help us simplify a lot of things for customers, like the antenna integrator we built, for example. Okay, it means somebody's interacting with the system, they're getting an answer, the problem solved, they move on. Okay, what's next is becoming more advanced and allow us and engineers to focus on innovation, what is looking at the future and what's next.
Awesome. Well, listen, Baha, great conversation. Thanks very much for spending time with us today. It was Baha Badran, Global VP of Engineering at Taoglas. I'm Dermot O'Shea, host of the Antenna Podcast. You can get more information on our website, theantennapodcast.com, and you can send us an email to me, Dermot, at the Antenna Podcast. So thanks, Baha.
Thank you, Dermot.